Understanding the solar power system. A solar power system consists of several interconnected components that work together to generate electricity from sunlight. To ensure a smooth startup process, it is essential to understand these components and their roles. 1. Solar panels. Solar panels, or photovoltaic (PV) modules, capture sunlight and convert it into direct current (DC) electricity. These panels are typically installed on rooftops or ground-mounted systems and serve as the primary source of power generation. 2. Solar inverter. The inverter is a critical component that converts DC electricity from the solar panels into alternating current (AC) electricity, which is compatible with household appliances and the electrical grid. 3. AC and DC disconnect switches. Disconnect switches allow for safe manual control of the power flow. The DC disconnect switch cuts off the flow of electricity from the panels to the inverter, while the AC disconnect switch isolates the inverter from the main electrical panel. 4. Main electrical panel. Breaker box. The main electrical panel distributes power to different circuits in the home. The solar system's breaker controls the flow of solar energy into the home and the grid. 5. Utility meter. The utility meter records the electricity generated by the solar system and tracks any excess energy sent to the grid. Steps to turn on your solar panels. 1. Ensure all connections are secure. Before turning on the system, inspect the wiring and connections. Loose or damaged cables can affect performance and pose safety hazards. 2. Switch on the solar breaker in the main electrical panel. Locate the solar breaker in the main electrical panel and switch it to the on position. This allows electricity to flow from the inverter to your home. 3. Turn on the AC disconnect. Switch. Find the AC disconnect switch, usually mounted near the inverter, and flip it to the on position. This step ensures that power can be delivered to the grid. 4. Activate the inverter. Most inverters have a power button or switch. Turn on the inverter and allow it to complete its startup sequence. Some inverters display indicator lights to show operational status. Green light. The system is running correctly. Yellow or orange light. The system is in standby mode or experiencing minor issues. Red light. A problem requires attention. 5. Switch on the DC disconnect. Once the inverter is operational, turn on the DC disconnect switch to allow power from the solar panels to reach the inverter. 6. Monitor system performance. Check the inverter display or monitoring software to ensure the system is generating power. If any error messages appear, refer to the manufacturer's guide or contact a professional technician. When to turn off solar panels. There are situations where turning off the solar system is necessary for safety and maintenance. 1. Routine maintenance and cleaning. If performing maintenance or cleaning solar panels, shut down the system to prevent electrical hazards. 2. System repairs. During component replacements or inverter troubleshooting, turning off the system ensures safety for homeowners and technicians. 3. Emergencies. In case of fire, electrical faults, or natural disasters such as wildfires, shutting down the system minimizes risks. 4. Extended periods of non-use. If leaving home for an extended time, shutting down the system may be recommended to protect it from potential damage. Common issues in troubleshooting. 1. Inverter not powering on. If the inverter fails to turn on, check the following. Ensure the main breaker is in the on position. Verify that the AC and DC disconnect switches are activated. Inspect for error messages on the inverter display. 2. Low or no power generation. If the system is not producing power, check for obstructions such as dirt or debris on the panels. Inspect wiring connections for damage. Review monitoring software for system alerts. 3. Utility meter. Not registering solar power. If the utility meter does not reflect solar energy production, confirm the system breaker is on. Contact your utility provider to verify meter settings. Best practices for long-term solar system performance. 1. Regular inspections. Schedule periodic inspections to check for wear and tear on components. 2. Clean solar panels. Dirt, dust, and debris reduce efficiency. Cleaning panels every few months ensures optimal energy absorption. 3. Monitor system performance. Use solar monitoring software to track energy production and detect issues early. 4. Upgrade components when necessary. Inverters and batteries may require replacement over time. Upgrading to newer models improves efficiency. 5. Work with certified solar installers. Professional installation and maintenance services help ensure system longevity and compliance with regulations. Columbus Solar Panels, trusted solar experts. At Columbus Solar Panels, we provide expert solar solutions in Columbus, OH, with a commitment to quality and customer satisfaction. Our BBB-accredited A+ rating reflects our dedication to excellence. We work with insurance companies and offer a variety of financing options to make solar energy accessible to more homeowners. Frequently asked questions. 1. What should I do if my solar panels are not producing electricity? Check the inverter status, inspect for loose wiring, and ensure that the breaker and disconnect switches are turned on. 2. Is it safe to turn on my solar panels by myself? Yes, as long as you follow proper steps and safety precautions. If unsure, consult a professional. 3. How often should I turn off my solar panels? Only turn off your solar system when necessary, such as during maintenance, repairs, or emergencies. 4. What happens if I forget to turn on my solar panels after an outage? Your system will not generate power until turned back on. Follow the startup steps to restore functionality. 5. Can solar panels be damaged if left on during severe weather? Most panels are designed to withstand harsh conditions. However, in cases of wildfires or extreme electrical storms, shutting down the system may be advisable. Conclusion. Turning on a solar panel system involves following a structured process to ensure safe and efficient operation. By understanding the system,